To obtain the vector or cross product of the two vectors A and B, we start by drawing the two vectors with their tails together at the same point. The two vectors then lie in a plane as shown here. The angle between the vectors is theta. The vector product of A and B is defined to be another vector, C, whose direction is always perpendicular to both A and B, and whose magnitude is equal to the magnitude of A times the magnitude of B times sine theta. I have shown the vector C pointing upwards here. However, the definition of the vector product stipulates that the vector C must be perpendicular to both A and B. So there are always two possible directions or senses for C. In this case, either upwards or downwards. Which sense is the correct one may be determined using what is known as the right-hand rule. Imagine rotating the vector A about the axis perpendicular to the plane in which A and B both lie. In order to line it up with the vector B, in other words, rotating it through the angle theta. If you imagine curling your fingers around the perpendicular axis in the same direction as the rotation of A to B, then your thumb will be pointing in the direction of the vector product C. Here, the rotation is anti-clockwise, and so the thumb points upwards. If instead we wanted to determine the vector product B cross A rather than A cross B, then we would need to rotate vector B to line up with vector A. Orienting the right hand so that your fingers curl in the same direction as the rotation should result in your thumb pointing downwards. So if the vector D is equal to the cross product B cross A, D must point downwards. This shows us that the vector product is not commutative. In other words, A cross B is not equal to B cross A. In fact, A cross B is equal to minus B cross A. So what is the geometrical interpretation of the vector product? What does it represent? Well, B sine theta is the component of B which is perpendicular to the direction of A. So the magnitude of A cross B is equal to the magnitude of A times the magnitude of the component of B, which is perpendicular to the direction of A. Alternatively, it may be considered as the magnitude of B times the magnitude of the component of A, which is perpendicular to the direction of B.